Hi class. Today I'm gonna talk about section 4.4 differentiating the natural exponential functions. So in this session we're gonna answer the question as what is the derivative of the natural exponential function. So the answer should be, the answer is derivative of natural exponential function is itself uh, is 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 its own derivative. Or I can say EX is its own derivative. Okay. So this is the formula for the derivative of natural exponential functions, which is d over dx of e to the x going to be equal to e to the x. Okay, so let's apply it in example 1 here. Okay, so in example 1 here, I noted that in globally I see that I am having a polynomial function multiplied with ex, which is a natural exponential function. So when you look globally, it actually is a product between two functions. So I'm gonna say is u and v, and I'm gonna let u equal to x cubed and v equal to e to the x. So when you take the video of that, for each one in here, I have e prime gonna be 8 times 3 equals 24, x power 3 minus 1 equal to 2. Right? And v prime will be the derivative of the ex, which is itself. So I'm gonna have e to the x. Okay. Apply the product rule, to find the f derivative of x will give you u prime times v plus v prime times u. And I'm gonna substitute all the u and u prime, v and v primes into here. So I'm gonna get u prime is 24 x squared times v is e to the x plus with v prime is e to the x, and mu is 8 to the x cubed. And last step, I would like to factor the graded common factors. So for these two terms, I noted that ax squared ex will be the graded common factor. So after you factor it out, you for the first term you will get you will still have 3 and then the last term is x. Excuse me. So that should be the answer for this problem. Now let's practice more in example 2. So example 2 is a very interesting example because in this example, I want you to find the equation of the tangent line to the curve 7x e to the x. So at the point 0, 0. So assume this is curve fx, right? And this is a point 0, 0. So the tangent line will go through this point and touch the curve at 0, 0. Okay. So this is a tangent line. Okay. So you need to find the equation of the tangent line. remember that this tangent line have a slope. They have slope of tangent line gonna be equal to the derivative of fx. Okay, slope of tangent gonna be equal to the derivative of fx, which, according to the definition of the derivative of fx. So you will have to find the derivative of fx. So which is so you're gonna see that here you also have like a polynomial 7x multiplied with derivative function. So I'm gonna say use and here's v. Okay. So now you are having a product. So you need to have u prime times v plus v prime times u. And if I want to do a side work, you can do if you can do in the head, that's good also. But for doing by a side, that make you more organized. Okay, so u gonna be 7x. U prime will be what? 7, right? It is constant. This is the derivative of a constant multiplied with x. So that's going to be just a constant. So v going to be e to the x, and then v prime just going to be the same, that e to the x. So now I'm going to apply that, apply this into the f derivative of x. I will have f derivative of x equal to e prime is 7 times u, times v, I mean, e to the x, right? Plus v prime is e to the x again, times u is 7x. And if you want, you can factor it, but in this case, I don't think I need to do it, because this is what it is a general slope. This general slope of tangent. Okay. So what is specific slope in this case? I need to apply at the point. The point 0, 0. Which mean what? We mean x in here equal to 0, right? X here, y here, right? X in here equals 0. So I need to find the slope at this point, right? So I have slope will be so I'm gonna apply x equals 0 into the general slope. So I have slope m equal to f derivative of 0, which equal to 7 and e to the 0 plus e to the 0 times 7 times 0. So this term will become 0. So, and e to the 0 will become 1. So I will have m equal to 7. All right. And now I will have to apply a point and a slope into the point slope formula for the in order to find the equation of the tangent line, right? So I'm gonna say apply point. What point does the line go to? 0, 0 is the point that tangent line go to, right? 0, 0, which is x1, y1, right? And slope m equals 7 into what? Into function into what I'm gonna just say into point slope formula. Slope for So we is y minus y1 equal to m times x minus x1. So you will have what? Y minus 0 equal to 7 times x minus 0. And because this case gonna easily to be simplified, so I'm gonna just simplify this to get y equal to 7x. So that should be the equation of the line, equation of tangent line at point 0, 0. Okay, so remember that. In this case, the line goes to 0, 0. Then you have this equation. If you have another point, say 0, 1, then it should be different equation than the line. Okay, so I'm gonna move up and talk more. Okay, so another question is, can I, what is derivative of composition what is a derivative of a composition function, or say composition exponential function? Okay, so what does that mean? That means like look globally. It still is an e to power something, which is like a function in this guy. So if you see you look globally and see a function like this, then how can you take advantage of that? Okay, so answer 2 will be using chain rule. Okay, chain rule for exponential function. Okay, so what is chain rule? Okay, chain rule for the exponential function. You did learn about chain rule already, right? Chain rule is always like the derivative of the inside function multiplied with, the derivative of outside function will multiply with the derivative of outside function, right? So in this case, inside function is g. Okay. So let me write. Inside function is g, right? And outside function is e to the z x. So so if you take the view of that, and the formula is gonna be e to the z e to the zx and multiply with the derivative of the power, right? See that? See the formula here. You're gonna see that the derivative of a composition exponential function is gonna be itself multiplied with the power derivative, right? Power derivative, right? So now I would like to apply that into example 3 and see what happens, right? So I have x equal to e to the 3x squared plus 5x, right? So I will apply it as become f derivative of x will be equal to itself, okay, e to the 3x. I can't have one more. Okay, so I'm gonna write that. So f derivative of x will be equal to, okay, itself e to the 3x squared plus 5x multiply with the power derivative, right? So what's the power derivative? 3x squared plus 5x and derivative of that. So you will have what? Is going to equal to e to the 3x squared plus 5x multiplied with 3x squared going to be equal to 6x. Okay, because 2 put down and x to power 2 minus 1 will be equal to 1. So plus with the 5. Okay, constant multiplied with an x. Derivative will be just constant, right? So that is the answer for this question. Okay. Let me make color. Okay. So that is done for example 3, and I would like to apply this, apply the derivative of exponential rule into like a conversion of natural log also. So in this case, you notice that you are having natural log of 2x plus e to the negative 0.05x, which is also a conversion function. When it look globally, it look like a natural function is ln of gx, right? So you're actually gonna when you take the view of that, or I'm gonna write gx as an argument better. So argument, right? Like the 4.43. So how can you take the view of natural log? You will have derivative going to be equal to 1 over argument multiplied with argument derivative. Okay, so what does that mean? I'm going to have 1 over argument. Argument in here is 2x plus e to negative 0.05x, right? And I'm going to have parentheses here to make sure I don't mess up with that. And I multiply with the argument derivative. Okay, so argument is 2x plus e to the negative 0.05x. Derivative of that. Okay, so you take the derivative of that. Okay, what you gonna have for the next step? Okay, next, and have 1 over 2x e plus, right? E to negative 0.05x. And I have parentheses to make sure I don't forget it. And I'm gonna have 2x, the derivative gonna be 2, right? And plus with, okay, now watch out with this guy, e to the negative 0.05x. So in this one, e to negative 2 power negative 0.05x is also like a composition function of the natural exponential function. So so you have to take care of this power derivative also, right? So it has to be equal to itself first, e to the negative 0.05x, and then you multiply with the power derivative. So it's going to be 0.05x derivative. Okay. And now you will have So the top, I can multiply this 1 by, with the next group, become a parenthesis of 2 plus e to negative 0.05x multiply with negative 0.05x derivative, which equal to negative 0.05. Okay, and I have 2x plus e to negative 0.05x. Okay, so this is FDV of x, right? What's the question? The question is asking us about find the FDV of 3. So I need to plug 3 into the FDV of x, right? Now 3 is input of FDV of x. So I have FDV of 3 equal to, okay? So top only 2 plus e to negative 0.05 times 3 multiply with negative 0.05. You know what? I'm gonna combine these two. So I'm gonna have minus 0.05 e to negative 0.05 times 3, right? So that is top, and bottom gonna be what? 2 times 3 plus e to negative 0.05 and 3. Okay, so now it's time to use a calculator. Okay, so here's my TI-83. Okay, and you are allowed to use your calculator TI-83 or scientific calculator, but not any other something like online calculator. So okay, now top I have to have parentheses 2 minus 0.05 times e. So I have little e in the division here. So second e to power negative 0.05 times 3. So put negative 0.0. Actually, I have to have parentheses first, right? Because this have two number 0.05 and 3. Okay, so I'm done with the top. So I put a close parenthesis and divide by, open up another parenthesis, 2 times 3 equals 6. And then I plus with e power negative 0.05. I have to have, let me see again. So this parenthesis negative 0.05 and 3. And then close the parenthesis. So I'm gonna have 0.28524. Okay, so 0.28524. F divided 3 will be equal to what? But they want us to have 4 decimal place. So let's see, 0.28552. So 0.2852, right? So with the approximate. Okay. So I have just finished example. Okay, now so I'm gonna label this as the answer. Now I would like to move to example 5, and I'm gonna move down here. Okay. Example 5. asking us about the second derivative of mx. So to find the second derivative, I need to find the first derivative of x, right? And then take derivative of it to get the second derivative of x. Okay, so in here, we noted that fx equal to e to the 2x squared plus 5. And look globally, it is what? It is a natural exponential function. Okay, so so you will have is equal to apply the derivative form of the composition function. You will have itself, so e to the 2x squared plus 5 multiply with the power derivative, right? So we're going to have what? Equal to e to the 2x squared plus 5 and plus 5, right? And 2x squared plus 5, derivative going to be 4x plus 0. So I'm just going to say 4x. Okay. And in short, I'm going to write as 4x times e to the 2x squared plus 5 like this. So that is for f derivative of x, right? Now I'm looking for the f second derivative of x by take derivative of that's one of the f derivative of x. So I'm gonna say take derivative of 4x e to the 2x squared plus 5, take derivative of that. And when you look globally, right, for this, you see that there is a polynomial function multiplied with a natural exponential function. Okay, so this is u and this is v, and you want to apply product rule. Okay, so u prime times v plus v prime times u. Okay, now time to do a side work with u is equal to 4x. So then u prime equal to 4, v equal to e to the 2x squared plus 5. So v prime will be the same as f derivative of x, right? So you're gonna easily get it as 4x and e to the 2x squared plus 5. Okay, so remember that v in here is look exactly is the original fx. So we're going to take derivative of that. It's going to be exactly as the f derivative of x, right? See that? Look exactly with the f derivative of x. Okay, so I would like to color this. Okay, and this. All right. So now let me get down here and substitute everything. I have f derivative of x will be what? U prime is 4. Okay. Times v e to the 2x squared plus 5. And plus v prime is 4x e to the 2x squared plus 5. And u is v prime times u is 4x. Okay. So, oh, I need to have double prime. Right? So in order to factor, in order to factor more, right? I factor this one. I would like to factor the greatest common factor up to this term. I have 4 of e to the 2x squared plus 5. And then multiply with the first one gonna have only 1 plus the second one gonna have 4x squared, right? Yes. Okay, so that should be the answer for problem number 5. Okay. So I need to note, maybe I'm gonna just note here for you to make sure you know that we read it. Factor for e power 2x squared plus 5. Okay, so this should be the answer. And now we will move to example 6. So in example 6, you are having mx equal to 6 times e to the negative 7x multiply with a ln of 5. So this actually is look like when you look globally, you have two kind of function here. One is the natural exponential function, and another one is natural log function. So so it's going to be look like a product rule between two kind of this function. So I'm going to have f derivative of x will be equal to u derivative of u derivative of v plus v derivative of u, and I'm going to have a side work and get less u equal to 6 e to negative 7 x, and that gonna give me, you know what, I don't need to put the 6 here. I should let u equal to e to negative 7x. So u here, I stay with 6 here, right? So I'm gonna let 6 outside here because 6 is a constant multiply with a function. So I just take the derivative of the functions, okay? And the constant stay. So I leave 6 outside there. Okay, now I have u equal to e to negative 7x. And u prime will be what? Itself, e to negative 7x, multiply with the power derivative, right? So negative 7x derivative. So that's going to give me what? U prime equal to e to negative 7x times negative 7. Okay, so I would love to put the negative 7 in the front, so make it more organized. So times e to negative 7x. Okay, so that should be the u derivative of x, u derivative, okay? And v equal to ln of 4x. And we'll have v prime equal to, okay, 1 over the argument. Argument in here is 4x, right? So 1 over 4x multiply with the argument derivative, 4x derivative. Okay, so let me move this down. Okay, so I will have v derivative will be equal to 4 derivative, 4x derivative going to be equal to 4 over 4x. That give me 1 over x as the v derivative. So I'm gonna color this. Okay. Now I come back with the problem and apply it. So I have f derivative of x will be equal to 6 times with parentheses. U prime is negative 7 e to negative 7x. Times v is ln for x plus v prime is 1 over x times use is e to the negative 7x. Okay, so now I would like to factor out the e to the negative 7x for these two terms, right? I will have f derivative of x equal to 6 times with e to the negative 7x. I factor it out already. And inside now gonna give me negative 7 times ln x plus 1 over x. And I think that should be the answer for f derivative of x. If you want to make it more nicer, you can make it like f derivative of x equal to 6e to the negative 7x times with 1 over x minus 7 ln x. That should look nicer for you, and that should be the answer. Okay. Okay, now I'm gonna move to example 7. Okay. So we did an some example with the product rule. Okay. Now how about the combination between quotient rule and the chain rule for natural exponential function. Okay, so example 7 is giving you mx equal to ex minus e to the negative x over ex plus e to the negative x. So this, look globally, you can see that is like a fraction. And it actually can be like a quotient between u over v, right? And you and in order to take the view of that, you need to say f derivative of x will be equal to u prime times v minus v prime times u, and you divide by v squared. Okay, that's formula for the quotient rule. Okay, now I'm gonna have to do a side work for u equal to e to the x minus e to the negative x. And u prime will be equal to e to the x, okay, itself, right? This is not it's just natural exponential function with no composition, so itself. So and then minus for the e to negative x. So this is a composition because the power now having a negative of x. It's not only x. So I have to have multiply with e to negative x itself, right? And multiply with the power which is negative x derivative, right? And I simplify to get e to the x minus. Okay, so negative of x derivative gonna be negative 1. So negative 1, I will multiply with negative outside here and to get that positive of e to negative of x. Okay, so that is the u derivative of x. And for v, I have e to the x plus e to the negative of x. And I take the derivative of that, I'm going to have e to the x because ex derivative is going to be ex, right? And for the next term, I'm going to take e I'm gonna have itself derivative of that gonna be itself multiply with the power, which is negative x derivative, right? So remember that the power in here is not x alone. It is with negative with something, right? So that is a composition function. So you need to use chain rule in here. And simplify, you have v prime going to be e to the x plus, no, actually minus e to negative of x. And calculate. So that is v prime. Now you want to apply everything into f derivative of x. I have f derivative of x equal to u prime going to be e to the x plus e to the negative x. And then multiply with the v is e to the x plus e to the negative x. And I subtract for the v prime e to the x plus e to the negative x. And no, not plus. Minus. So this is v prime. So I have minus. All right. Time u, which is e to the x minus e to the negative of x. Okay. So what does it look like? Okay, let me have the v squared at the bottom. So I'm gonna make sure I have u's prime times v minus v prime times u. Okay, everything is good. So e to the x plus e to the negative x squared. Okay, move down. Okay, so now I'm gonna look back what we are doing. We are looking for f derivative of 0. So in this case, you can simplify one more time, or you can even apply x equals 0 into f derivative of x right away. I would like to simplify a little bit more, one more step. So I have f derivative of x will be equal to, say, e to the x plus e to the negative x square. I don't have enough space. Let me move down. X go to e to the x plus e to the negative x square. And then a minus for with e to the x minus e to the negative x and square. And then e to the x plus e to the negative x square. So you can see that it is like you know what? I'm just gonna apply apply 0 into here. So I have f of 0 will be what? E to the 0 plus e to the negative 0 and square minus for the e 0 minus e to the negative 0 square divided by e to 0 plus e to the negative 0 and square. So I'm gonna have this e0, e to the power 0 is always equal to 1. Okay, so I would love to say here's 1, here's another 1, here's 1, here's another number 1. Here is 1, 1. Okay. So now I have 1 plus 1 square minus for 1 minus 1 square and divided by 1 plus 1 square. Okay. And this will give me top is 4, bottom is 4, and the final answer has to be equal to 1. That is attribute of 0. Okay. The question doesn't ask you to interpret this function, but if you consider or in the future, if a question asking you about interpret the function, so then you're gonna say if x increase 1 unit in value from 0 to 1, then the function f(x) will increase in value by approximately 1 unit, right? And remember that we need to say approximately, okay? Now we're gonna talk about, now we actually have like some special case for exponential function. So the first case is, so I have special case in here is when you take the derivative of the exponential function with e to a constant multiplied with x, then you can right away have the constant multiply with the e to the ax. Why it happened like that? You actually can still apply chain rule here to derive this, right? So you have like e to the ax, the derivative will be equal to itself e to the ax, and multiply with the power with a to the ax derivative. And since a is a constant multiplied with x, when you take the derivative of that, it's gonna be let's just have e to the ax first, and it should, and the ax derivative will be equal to a. So when you make it try to make it look like the form, you can from here you can right away come to this. So in short, you see that if you're taking a derivative of a natural exponential function, you will with the power as with a constant multiply with an x, then you're gonna just have constant multiply with a natural exponential function. Okay. So let's apply that in example 8 here. Okay. So I have, let me do quick on problem A. I have, actually I have solution for A already. So look at problem A. You see that easily I'm gonna I want to take the view of e to the power x in here. In this case, for the power of is 4x, and 4 is constant. So I put down this 4 to the front of e to the 4x, and that's going to be the derivative of that. Okay. So, and another one in and B, I have -6 e to the -6x. Then I just gonna move -6 to the front of e to the -6x, and that should be the derivative of e to the -6x. And now I have combining things between a constant multiplied with e to the -0.5 0.2x. Then I had to have have to put the negative 0.2 in front of the function. We multiply with 5 later, and multiply with the same excuse me natural exponential function, and you combine the negative 0.2 with 5, and you have -1. So you're gonna have negative e to power negative 0.2x. So that should be the way to apply this special case, right? Okay, now I'm gonna move to let's see. I'm gonna move to example 9. Okay. So example 9 is example 9 is word problems, and that may appear in your quiz or homework later. So you should try to know how to present for these columns by writings, because you need to show the work in the quiz, something like that, right? So in here it's talking about the resale value R in dollar of a particular type of laser cutting tool TGS after its initial purchase is approximated by RT equal to 450,000 times e to the negative 0.27 t. So they say find and interpret the rate at which the resale value is changing. Okay. A, what is the decay rate of the resale value? So decay rate, okay. Yeah, if you remember that I did talk about decay rate in exponential function already, which is gonna be the constant next to the variable in the power of the e in here, right? So which is negative 0.27. So so I could easily say that the decay rate is negative 0.27. Okay. And come back to the solution here. Is say from reading the general form of the natural exponential function, a equals to a0 times e to negative k. The decay rate is negative 0.27, which is equal to negative 27%. I don't care about the which form you like to use, but I'm just going to use negative 0.27. That's fine. It's same with negative 27%. Okay, so now for B, it's a 1 year after the initial purchase. What does that mean? That means in this case, T equal to, let me see, T is years after initial purchase, right? So T equal to 1, right? So you need to find the rate at which the resale value is changing. So in order to find the rate of change at this point, or like a instantaneous rate of change at this point, you actually had to take the view of that, of the resale value. So which means you are taking the view of R at t equal to 1. So you firstly need to find the R derivative of X and plug in 1 into it. Okay. So in here, in order to find R, the derivative of resale, you have to notice that we have this is the constant 450,000. It has to be stay, and then apply the special case above. You're gonna leave negative 0.27 in front of the function. So now you have negative 0.27 here, multiply with 450 times 40,000 times e to the negative 0.27 t. And when you combine, it's going to be equal to negative 121,500 e to negative 0.27 t. So so easily you're gonna get the for the review of resale gonna be negative 1.1 negative 121,500 times e to the negative 0.27 t. That is for the resale value, and you for this resale value you can notice that that is just general changing or general rate of change. So so you need to find a specific point when t equal to 1 for problem B, right? So in problem B, you are looking for degree of R when t equals to 1. So you have you have to plug in. You have to plug in t equal to 1 in this case. Okay, so okay, and now you're gonna have to substitute 1 into that, and then using the calculator. So so you have negative, and we'll have. Let's see what happened with my calculator. Okay. So, oops. So I have negative. Oh, what happened? Call this. Use my calculator again. TI 83. Oh, it doesn't work. What happened? Should work. Okay, now you have clear this and negative 121,500 times e second division power negative. You have to balance it. negative 0.27 times 1. Oh, actually, you know what? You don't need to times 1. So it's going to set negative 0.27. And enter that's going to be negative 9270.61 approximately. And let's see in our question, they didn't ask us to round it up to 2 decimal place. So this depending if you like to have only 2 decimal place, you can just write it up to 2 decimal place. So in this in the solution here, we did round it to the 2 decimal place. And for C, okay, let's do C. It's a 5 years after the initial purchase. That means what? That means T equal to 5, right? And we are looking for R derivative of 5. And now I'm gonna have R derivative of 5. Right? We equal to what? Negative 1 to 1 500 times e to power negative 0.27 times 5. Okay, so what is that going to equal to? Need to use calculator again. So negative 1 to 1 500 times e to power parentheses negative 0.27 times with 5. I need to have times 5. You know what? Multiply with 5. Close that. And then there we have negative 301.71. Negative 3011 to negative 3 I forgot 0.71. And I think I need to put approximate. So approximate. Okay, so this should be the answer for the derivative of R at t equal to 5. So when you want to interpret this answer, okay, you can say that for the B, I should have B first. Let's see later on. Oh, see. B is if the number of years since the initial purchase of laser cutting tool increase by 1 from 1 to 2, okay, then the resale value of tool can be expected to decrease by approximately 92,750.61 cents. So usually, because this is talking about dollars, so then you need to round 2 decimal. For C interpret, you just gonna say, I just like to say shortcut. So says if T or it's say if T no, just say like if the number of years since the initial purchase because T is that, right? Increase from increase by 1 from 5, right? From 5 to 6. Then the resale value of the tool can be decreased by approximately 30111 $71. Okay, so that should be the answer for example 9. And now this is the last example for group work. I mean for the word problems. So let me finish this. If a person takes a prescribed dose of 5 milligrams of Valium, the amount of volume in a person's bloodstream at any time can be modeled with exponential decay function at equal to 5 times e to the negative 0.0144 t, where t is in hours. Okay, how much volume remains in the person blood stream 24 hours after taking 5 milligram dose? So you will need to round to the nearest 10 milligram. So let's do a problem A, right? So they say how much volume remain in the person bloodstream 24 hours. So in this case, you should need to, let me see. You should need to find the amount of volume after 24 hours. So what does that mean? That means T equal to 24. And you are looking for A at 24. Go to what? So A at T equals to 24 gonna be equal to 5 times E to power negative 0.0144 times T, which is 24. Okay, so you will have what? Equal to 5. You know what? I'm gonna use calculator here. So 5. Oh, it's again 5 time with E to power parentheses negative 0.0144 time with 24 and close parentheses. Enter that. It's gonna have 3.53. Okay, 3.53. So we're gonna put 3.5 because why? Because they say round to the nearest 10 milligram. So you say 3.5 milligram. Okay. And the answer should be like 3.5 milligram remain of volume remains in the person blood stream 24 hours after taking a 5 milligram dose. So that is A. For B, it say how long will it take 5 milligram to decay 2.5. So in this case, you are not given the T. You are given the amount remain, okay, which is A. So you need A of T equals to 2.5. And you're going to substitute 2.5 into the model and get AT equal to 5 times e to negative 0.0144 t. So what you're going to do is, this one is very good example, so focus on this. So you are solving for t in this case, and to solve for t, but t now in the power, right? You need to separate. I mean, you need to first substitute it first, right? So you have 2.5 for a of t, right, equal to 5 times e to power negative 0.0144 t, right? So so in order to solve for t, you need to separate the exponential form alone, which means what? It means you divide both inside by 5. So I have 2.5 divided by 5 equal to, let me write better. So I have 2.5 divided by 5 equal to e to the negative 0.0144 t. And now you may gonna use calculator to divide 2.5 by 5. So I have 2. What happened? 1 second. 2.5 divided by 5 equal to 0.5. So we have 0.5 equal to e to the negative 0.0144 t. Okay, keep in mind that the t now is in the power, and you also have like an exponential form in this case, right? So you need to, when you want to solve it, you need to think about using the definition of the log and change it to be the log form. So or you can just do log, natural log both hand side. Okay, so natural log both hand side. I have ln of 0.5 equal to ln of e to negative 0.0144 t. Okay, so in this case, if you remember, the probability number 3, no, number 5 of the natural log, you can put down the power here in front of the natural log. So you have ln 0.5 equal to negative 0.0144 t times ln e. Okay, so in this case, ln e will be equal to 1. Okay, that's one of the properties in ln in natural log, and you will have ln 0.5 equal to negative 0.0144 t, and you're going to divide by both sides by negative 0.0144 to get t, right? So t equal to ln of 0.5 over negative 0.0144. And in order to do that, you need to use a calculator. So you have, say, ln of 0.5 divided by parenthesis with a negative of 0.0144 and close the parentheses and enter. You're going to have 48.1. So 48.1, or I can say 48 hours. Let's see if they want us to route anything. They didn't ask anything. And since they didn't ask to write anything, I can just say like 48 hours approximately. Okay, to get to 5 milligram to be decayed to 2.5 milligram in person bloodstream. Okay, so if you want to interpret that, right, you say let's see, after 48 hours, 5 milligram of valium will decay to, or will be decayed, just like will decay to 2.5 milligram in person plus stream. Okay. Lastly, problem C. Okay. At what rate is amount of volume in person bloodstream decay faster after 5 milligram dose is taken, and round the rate to the 3 decimal place. So remember that in this case, they ask you about the rate that the amount of volume in person decaying 5 hours after. So what does that mean? So you will have to find additive of t and add t equal to 5, right? So you're gonna have 5 additive of 5. What is that equal to? Okay, so let's do it. We know that what is it? What's the RT? I wanna. Oh, actually, no, not R. A. It's A. Right. Okay. And I would like to write the model of A equal to 5 times 5 times E over here. 5 times e to the negative 0.0144 t. So in order to take the view of that, I'm gonna put down the power, right? Because in here I see the power as a constant multiplied with t. So I'm gonna put down the negative 0.0144 and multiply by 5 and multiply with the exponential, natural exponential itself form. Okay, and if you want to combine it, you're gonna have what? Say, negative 0.00, no. How many zero do we have? One, right? Yeah. Okay, so 144. And now it's gonna be multiplied with multiply with e no 5 and time e, oops, to power no, actually, you know what, I don't need this at all. Why I have to do that? Just multiply 5 and then have 0.072 0.072 e to negative 0.0144 t. I'm sure. Okay. So now that is for a derivative of t. Now I'm gonna find a derivative of 5. Right. I will have what? 0. No, this should be negative also. Negative 0.072 e to the negative 0.0144 times with the 5. And what is that equal to? Multiply with 0, no, I need to have negative 0.072 times e to negative power plus c negative 0.0144 times with 5, and that should be the answer as negative 0.0669. Okay, let me see. Round the rate to the 3 decimal place. Okay, so that's going to be negative 0.07. Negative 0.07 approximately. Oh, wait. 0.767. Sorry. 3 decimal place. Okay. So, okay, so if you want to interpret that, you're going to say the amount of okay, so the amount of volume in person plus stream is is decreasing approximately 0.067 milligram after 5 hours. After 5 hours, how can I say? Let me see. Should be if the number. Okay, I don't say that. If the hours after taking 5 milligram, right, 5 milligram dose of Valium is what's that? Is increased by, okay. So increase by 1 from 5 to 6 hours. Then the amount of volume in person bloodstream is decreasing approximately 0.067 milligram. Okay, so I have finished my section 4.4, and go ahead, do your homework, assignments, and prepare for the quiz. With you in on Sunday this week, and I see you next week. Have a good day.